What's good, everyone? In this video, we'll be covering another topic surrounding vLLM. I know that's kind of the model serving engine we've been standardizing on in all these different Gen AI videos, if you've been kind of keeping up with the series. But what we'll do is we'll explore the vLLM integration with SageMaker, which we talked about in the LMI v16 video. I'll link that down below. We'll continue to use these managed SageMaker images that integrate with this model serving engine. But today, we'll specifically talk about enabling tool calling on SageMaker. So SageMaker, it's pretty simple to kind of deploy large language models as we've seen through these managed images and the managed scaling and everything that comes with the different hosting options. But with agents and the way things are nowadays with LLMs, right? For most of them to be used in a production grade type setting, in a real world application, you need to enable tool calling in one way or another. So we'll take a look at how can we deploy a model on SageMaker, and then how can we enable tool calling itself with that hosted model in a way that's easy for you to kind of plug into a real world application for your own use case. Now, there's a few different methods or ways of doing this. And the popular one that we've heard about is LangChain, right? The orchestration framework, where you can simply provide the model provider and your hosted model, whether you've self-hosted it or whether it's through something serverless like Bedrock or like Anthropic's API, things of that sort. Versus what we'll cover today is how can we enable it directly through tooling via the vLLM specs itself, which we're working with through this container, right? So there's two different options. LangChain, we'll explore another time how you can integrate it with SageMaker. If you already have familiarity with LangChain, you'll know that it's a pretty easy framework to set up, and it makes more sense, especially for more advanced use cases. But we'll dive into those nuances and kind of differences here before we get hands-on. And like always, like I just mentioned, we will get hands-on. We'll showcase an example of using that large model inference container and enabling tool calling via that container using the vLLM serving engine. And you'll get good understanding of this coming out of this in terms of how can enable tools with a SageMaker hosted endpoint, basically, or an LLM that's hosted on SageMaker real-time endpoints. So with that being said, let's dive into the first thing I wanted to clarify, because this might be a little confusing for those of you that are a little newer to this world. And obviously there's so many different ways of solving the same problems. We'll explore how you can tackle building agents with SageMaker using both of these methods. But first, we'll talk about the difference here. And then, like I said, we're going to be focused on tool calling with vLLM specifically and using our serving container there. So with LangChain, as we know, it's a high-level orchestration framework. There's pre-built constructs for agents, for tools, which you can define. And we know there's also RAG-based chains that you can make. And via these chains, you can define prompts and more things of that sort. So there's objects for each of these that really simplify kind of the agentic building process. And I'll link my LangChain intro video down below as well. But with these, right, it really kind of simplifies the process where you can just bring your model, you can bring your prompts, you can bring your Python functions you want converted into tools. And LangChain gives these higher level constructs that makes it very simple. And the beautiful part about LangChain especially, right, is it's model provider agnostic. So whether you're coming from something like Bedrock or OpenAI, or even self-hosting on like something like SageMaker or something of that sort, you can bring a model from anywhere basically with LangChain. So it's very, very powerful and it's very high level in that sense. And the thing is, it can also get deeper, right? So when you have more complex workflows, such as multi-agentic systems, which are also becoming popular, right? There's lower level constructs such as LangGraph, which is a multi-agent framework that is kind of in that same LangChain ecosystem in terms of everything. And here you can manage things such as state, like long-term memory, things of that sort that you're working with. Even more of these constructs are basically introduced. State, as we know in our multi-agent series, is kind of the big thing that matters in multi-agent systems, especially as we make them more and more robust and sophisticated. So with the LangChain-based world, these higher-level constructs and these different frameworks let for you to deal with more complex agentic workflows, because a lot of this work is taken care of for you, and these constructs are provided basically. So you can focus really on just bringing your workflow and porting them over to these predefined constructs and frameworks that LangChain provides. That's where it's super neat and helpful. But now let's say, right, that we have an agent or a hosted LLM using something like SageMaker, right, with vLLM. And technically with vLLM, like I said, we're going to use the managed vLLM image via the large model inference container on SageMaker. You can technically use the vLLM image anywhere and this tool calling anywhere as well. So you're not forced to use SageMaker. That's the hosting choice we're going to be working with here. But if you have vLLM on something like EC2 or your own virtual machine, As long as you have that image pulled down, you can go that route too. But here, let's say we have our self-hosted LLM on SageMaker with vLLM using the LMI container, right, that we've been talking about. LMI, once again, I keep saying it, probably should have clarified, is the large model inference container, which fronts the vLLM serving engine. But basically, let's say we have that, right? And then we only have like one or two tools that we need to use, like tool 1, tool 2. It's not very complicated. We just need our self-hosted LLM to pick the right tool to use, right? In cases like this, where it's very simple, there's not many different moving parts in your GenAI application, sometimes it's much easier to just use the vLLM tooled spec. And within this, right, in those messages, if we remember, when you pass in a payload to vLLM, you have your system prompt, and that defines the instructions. You have your user, and then you have your AI, or kind of like the LLM that's responding, right? To this, basically, this entire messages schema, this format, you can basically add a tool definition. And in this tool definition, right, I think it follows the open API specs. It might look very verbose at first, but when you look at it, it'll start making intuitive sense. In this tool definition, basically, you point towards your Python function, and then you point towards the parameters that are necessary, and then you explain what needs to be returned. And obviously, you can follow best practices like using something like Pydantic to kind of clearly define the types of these input and output kind of specs that we're dealing with. But we essentially can attach this tool definition to each of our tools to our input messages that we're going to be passing to our model. And based off that, and when we enable tool calling, right, this is going to be another parameter that we enable that you'll see in this example. It will then understand, the serving engine will understand, okay, there is scope to use a tool here. These are the provided tool specs that I have baked into my system, into my prompting and the messages API that is being sent here, basically. So we add these definitions into our input schema itself that we're going to be sending. And this will obviously look a lot cleaner when we look at the actual code itself. But once again, right, returning to the main point, when would I use this versus LangChain? In the case that you have a very simplistic tool-based workflow where you only have a few tools that you might be working with and you're already using the vLLM serving engine, it's pretty easy to hook up and you don't have to overcomplicate things and you don't have to deal with the extra constructs or the syntax of LangChain. You can keep everything within this vLLM scope. But let's say your agentic or GenAI workflows become more and more complicated, where there's many different agents and many moving parts, then you can understand why we need a higher level framework such as LangChain or LangGraph, where many of these things are predefined for us and that we can use pretty easily. Because you can still bring a vLLM hosted SageMaker endpoint to LangChain as the LLM provider of choice, right? And that's something we'll explore in the coming video in terms of the other option here. But in the case, right, like you'll see in the sample, when you just have one or two tools that you know need to be executed, and it's a very rigid kind of setup and a very minimalistic setup, I think that's a better word there, then using vLLM natively is pretty simple. You stay within that framework, you define it within that messages schema, and you have everything on that single layer, basically. So for the sake of today, right, what we're going to do is we're going to show you how you can use vLLM via the managed LMI container that SageMaker provides, and then enable some tool calling within that. So with that being said, let me get out of the whiteboard as always. Those are all my YouTube videos there. And let's hop into our notebook. So we're in our familiar space that we're always in. We're in our SageMaker AI console here. I have a classic notebook instance, M5X large. I'm not pulling any model artifacts down into the instance. So that's why I'm doing that right here. I'm just going to provide the Hugging Face model ID for our sample. I'm also going to attach the documentation here for tool calling by vLLM. I've added all the resources that I kind of referred to through this. One of my colleagues also put out a great blog here. Feel free to check it out as well in terms of just if you want to explore or play with this more. But with that being said, for the purpose of today's notebook, right, what we'll work with, and this is in that same Git repo that I've been pushing everything to, and I'll share this in the description as well. For the purpose of today's video, right, we'll take the LMI container, specify the vLLM backend serving engine once again, and then more specifically, we're going to build upon that LMI v16 intro video and showcase how can we add tool calling in this tool specs. So if it didn't make sense in my very poorly drawn whiteboard right there, it'll make some more sense when you see the code here. So in this classic notebook instance, I'm going to install SageMaker Boto 3. You can use either the SDKs to interface with the service, whatever you're comfortable with, right? I'm going to set that up here. And then for my deployment, I don't want to spend too much time on this. Like I said, reference the V16 video if you want to understand more in terms of what exactly this LMI container is. But here I specify a few different things. The model we're going to be working with, your token. I need to start deleting. I keep deleting these at a record right now. But specify your token to be able to pull this code down. And we're going to be using the vLLM async engine as our backend, basically, which is the recommended serving engine, starting with this version especially. Now, the things that we're going to add, the two flags we're going to add so our serving engine knows that we're enabling tool choice, is we're going to say this number one. So we're going to tell vLLM, hey, pick basically the tool, or the LM, sorry, here, pick the tool that makes the most sense here. And then there's different tool parsers, right, which are once again scoped to different models in terms of what you're working with. For Quen, it's a Hermes-based tool parser to understand your tool spec basically and kind of translate it into what the model will understand. So you can see that all in the docs in terms of what tool parsers correlate with what different model families. But here I'm enabling most of the same parameters that we already talked about. The only things we're doing here is we're going to add these tool flags right here to make it clear that we're working with tooling. I then take the higher level SageMaker Python SDK, and I'm going to pass in this vLLM kind of serving properties basically, and say this is my serving stack that I want with my container image, and then create also an inference component. If you remember with inference components, you can specify the hardware on a per model and per container basis, and you can enable scaling too. And I know I keep saying this, but we will make a video on how you can scale inference components as well in terms of the copies and stuff. The reason this is recommended, right, is most LLMs have a certain amount of resource requirements basically for each LLM in terms of being able to host them. So we recommend the inference component world, especially when you're going into a real world production setting where you probably have multiple LLMs or models that you're working with. So we've enabled that. This is going to create a persistent REST endpoint, but it's also going to create a inference component. And you can visualize once again all this in the Studio UI. I think it's going, I don't know if it's in the console yet, but you can also visualize your endpoint here too. So the endpoint that we've created. And once again, make sure that you delete these. You do not want to incur GPU-based costs for too long. But if we come here to deployments and we click endpoints, we're going to see the created endpoint that we have. And then for our inference component, you're going to basically see this model, which is your different components. You can see the resources that you've allocated for it and any scaling, which we didn't do in this case, but you can also have that enabled there. Then just to make sure this is working as expected, we ask my age-old prompt, who is Roger Federer, and then we pass in this invoke endpoint API call here. A little bit of a silly response from the model, but maybe something that I'm kind of messing up with our parameters here. And then what I'm going to do here, right, is now let's get to our actual tool enabling. So what I wanted to do for this sample is build a very minimalistic tool. I'm going to say I have a mock database right here. You can imagine this being like your actual database or something of that sort that you maybe want to give your LLM access to. And I'm going to say I have a bunch of dummy names here with occupation, gender, and kind of interests. And what I want is anytime there's a prompt that's asking for information about someone, that we want to reference this database. Basically, it's just a dictionary here, but we want to reference this database and return the information about that person, basically. So then this is my actual function, and this is my actual like backend logic, right? So just like you would in a non-tool based or non-agentic world, this is the same backend logic you'd have in a traditional kind of software set. But now the agentic part, right, is defining the tool itself. So this tool spec that I was talking about, right, is what points towards this function. So I'm going to say I have a Python function I'm dealing with. This is the name of it, so that vLLM can pick up on this. I'm going to give a description, and you want to make this verbose and clear, right? If this is not good, this is the instructions that are getting fed into your LLM. So it's only going to be as good as the info that's fed in. And I'm going to define my parameters. So I'm going to say we need a name, no matter what, to be able to access this. If it's not there, we're going to return an error, basically, right, in terms of that name was not found. And we're going to say the type. So the property is string right here. And you can imagine as your tools get a little more complicated, you can enable the different parameters and any required ones. So maybe in certain use cases, right, there might be some optional flags or parameters you don't need. But essentially within this tool spec, we define this. And all of them fit within this, right? All of them fit within this open API spec. I believe that's what it's called here. And that's going to be our tool. So our tool here, we're going to pass in that spec, which is pointing towards our function that we've defined here, essentially. And now I'm going to have a few different utility functions. This might look like a lot at once, but let's decompose this slowly. So number one, right, the difference, another key difference here with tool calling via vLLM is it won't execute the tool for you. So when you initially invoke, and this is the key part here in this video, when you initially invoke the model or the endpoint, right, with your input prompt, the first response is actually going to be saying, did I detect that we need to make a tool call, or can I just return a normal answer for this? So in the case, right, that there is a tool call detected, you actually need to parse the input that it's picked up on and the name of the function or tool that it wants to invoke and feed that in to the function itself. So what you can think of, this is kind of similar to the Anthropic API video that we had in terms of how tool calling works there. What it will do is upon initial invocation, it will say, okay, you should be using a tool. Here's the input prompt that I picked up on or the input parameters. And here is the function name or the tool name that I picked up on. And what you have to do is, right, you have the control within yourself basically to basically say, okay, I see this now. I'm going to enter in the input it picked up on into my Python function, grab that output, and then I'm going to pass that back in to the messages API that I've initially sent. I'm going to append it to that basically, and then I'll hit my endpoint again. So this is a little different, right? Whereas LangChain kind of takes care of that and executes the tool for you. The tool execution control falls for the end user. So when the input comes back in that a tool call has been defined, it is your responsibility to execute that tool or that Python function with the inputs it's picked up on, and then append that output from the function and send that back to the model to give a structured response. So there's actually two invoke endpoint API calls that will be happening here, right? So one of the utilities here, this invoke EP API call, is just hitting our inference component that we're dealing with, our endpoint, which is backing that inference component. But the actual handling of the tool calls, right, like I was saying, is when we get our result back, we're going to parse to see if there were any tool calls. If it was empty, right, we are just going to return the content. That means it chose not to use a tool. It's just going to execute whatever else was there. If it was not empty and it's saying we should be executing a tool, what we're going to do then is, in the case that let's say it's more than one tool, that's why we're doing a loop here. We're going to parse for that tool calling ID, which is its identifier right there. We're going to parse for the name, and we're going to parse for the arguments that are existing within that tool that it picked up on. And what we're going to do is we're then going to execute this. So we can execute this tool call. So basically pass it into this Python function that we've defined here, get that output back. So that's our tool output. And then we're going to append it to our initial messages structure. So if we see what our messages structure looks like right here, right? And I'll explain what each of these are in a second. We have our system prompt, and then we have our user input right here. So the system prompt, I'm basically saying, hey, you're an assistant with access to tools. Use this biodata tool when the user asks for information about specific people. Once again, your system prompt should follow best practice here. Make it as clear as possible, concise too. You don't want to overwhelm it with too much information here. And keep in mind context windows for different LLMs. But essentially, right, that's our initial messages API. But in the case that a tool is hit, whether it's a singular one or multiple, basically, we then want this we want to be able to execute the tool here, which is what's happening here. And then we're essentially going to append to that initial messages structure that we've shared with the tool output, and then we feed back into the invoke endpoint API call, right? And you can see all that logic finally here in this chat with tools. This is kind of the wrapper method of everything. We're going to have our payload, we're going to have our tools, we're going to have our tool choice saying auto, which is basically telling the server or the LLM kind of pick which tool to use. And we invoke the endpoint initially, we get this back, and if we see that there's no initial content, right? Or sorry, no tool calls were made, we're just going to return the initial result. If it's not there, then we're going to go through this loop where we execute all the tool calls that our LLM is suggesting, basically. We execute that, and you'll see there's another invoke EP call once this message structure has been appended with that. So this might be a little confusing or counterintuitive at first, but the main essence here is, right, that tool execution is in your control. That initial invoke to the model is only going to say, should we be using a tool call, or here's your output and there's no tool call that's needed. So with that being said, right, here's a few examples of each of these different cases. In this case, I'm just asking it, what is the capital of France? According to my system prompt, it should not be using a biodata tool whatsoever. It should just use its general knowledge here, like I was specifying. Same here with the single tool. I'm saying who's Shyam, and if we remember in our database here, our dummy database here, it should use the tool and retrieve that. And then I give a slightly more complicated prompt where I say, what is the combined age of Ram and Shyam? This should in reality execute two tools, right? Or execute the same tool twice. It should check for my age, then it should check for Shyam's age, and then use its general math knowledge to be able to solve this. And we can kind of see this in action here, right? I should have probably delimited this a little better. But if we see here for the first prompt, which is a simple one with no tools, we'll see it's understanding that it doesn't need to use the biodata function. It can answer directly and it says it's Paris for the capital of France. And then here for who is Xiam, it uses the return biodata tool to get that information. So it's picking up as expected. So it gets the age, 22-year-old male, who works as a doctor, which hopefully should be correct with this dummy data here. Right there, you see that information. And then finally, in the case, right, that we want a combined age, we actually need the tool executed twice. So it calls that return by data function for both names, Ram 25, Shyam 22, and it adds those two together. So basically it loops through the different tool calls that are suggested basically in terms of what's happening, right? And you can also add print statements through these functions I've shared there to kind of see that functionality end to end. But yeah, at a high level, that's mainly what I wanted to share today. I know this might be a little bit new and it might seem a little more verbose at first, but there's certainly a use case. You're already in the vLLM ecosystem and you don't have a necessarily super complicated kind of use case, right? And I honestly suggest, like, the more and more people I've talked to, right, a lot of people are kind of gung-ho on going multi-agents or hundreds of tools or things of that sort. That's not always needed. You're going to have use cases where you might just have a few tools or even a singular tool that your agent needs to be executed. And in cases like that, especially when you're already working in the vLLM ecosystem, it might be easy to just keep the stack simple and just kind of have it through this. Now, that being said, there's a counter case of, let's say we have multiple agents and multiple separate tools, hundreds of tools that we have to work with. This is going to get complicated very, very quickly. And that's where multi-agentic frameworks like LangGraph, Strands, I think also, what are other ones? Crew AI as well. There's so many other options, right? That's when we have to start thinking of using those frameworks. That's where I differentiate these two options. And with the purpose of this video, I want to introduce you to at least one option in terms of how you could be interfacing with tools through SageMaker. The second option, right, is integrating it with something like LangChain. And that's something that we'll explore in a coming video. And remember for tool calling, right, not all models that are on Jumpstart or not all LLMs natively support tool calling. So you want to make sure whatever LLM you pick has that support too, regardless of the approach that you go. But yeah, at a high level, that was mainly what I had for today. I realize I say that a lot, actually. I don't know how to end most of these videos. But if you have any questions, please leave them down below in the comments. Feel free to reach out to me directly on LinkedIn, Twitter, wherever it is that you're comfortable, and I'll do my best to get back to it. Hope it was helpful, and if you enjoyed the video, feel free to leave a like and subscribe. Like I said, plenty more to come in this area. Thank you, everyone, and have a good day.